Today, we're going to talk about the mean value theorem for derivatives. So what the mean value theorem for derivatives says is that if you have a continuous and differentiable function in the interval a to b, then there exists a value c in that interval a to b such that the derivative at c is equal to the average slope of the entire interval. For example, let's say we have this smooth continuous differentiable function. So this right here is just the slope between f of b and f of a, or the slope between here and here. And the mean value theorem tells us that there's at least one value c in this interval such that the derivative at c is equal to the slope of this overall line. Here, there are actually three. They're here, here, and here. So the reason why this works is you can think of this overall slope kind of like the average derivative on this interval. And on this graph, we can see that there are derivatives that are greater and less than the average derivative value. So we're told that the function is continuous, but that also means the derivative has to be continuous. And so that means to get from this high derivative to the low derivative, we have to pass through every point in between. And of course, this has to include the average value itself. And this works the other way too. If we want to go from a lower derivative to a higher derivative, we have to pass through every derivative value in between, which must include our average value. Now we're going to move to Rolle's theorem, and you'll see that it's pretty much the exact same thing as the mean value theorem, except we have this additional condition that the endpoints must be equal. If that applies, then we see that the guaranteed value of the derivative is 0. To see why that is, we're again going to look at it graphically. So I have this function is continuous, differentiable, and f of a equals f of b. If I want to find the overall slope in the interval, or the average derivative, then I just take the slope between this point and this point. But since f of a equals f of b, this on top goes to 0, so our slope across these 2 points is just 0. Then by the same argument we made in the mean value theorem, we're guaranteed a value c such that its derivative equals 0. So remember that our function is again continuous, and that also means its derivative is continuous. Again, we also see that there are derivatives lower than 0 and derivatives higher than 0. That means at some point between here and here, the derivative equals 0 because the derivative is continuous. We see that these points are here and here. To finish the video, I'm going to do an example problem. Consider f of x equals x times square root of x plus 4 in the interval minus 4 to 0. Then, if Rolle's theorem applies, we're going to find the c such that the derivative at c equals 0. First, we need to check if Rolle's theorem actually applies. And we already know that this is continuous and differentiable, so we just need to check that f of a equals f of b. And we see that f of negative 4 and f of 0 both equal 0, so Rolle's theorem does apply. So now that we've guaranteed that some value of c actually exists, we're going to go ahead and find it by differentiating f and setting it equal to 0 and solving for x. I have f equals x times root x plus 4. If you look here, this is a product of two functions, so we need to use the product rule to differentiate this, like so, which simplifies to this. Now we're going to set this equal to 0 and solve for x. So what I'm going to do first is I'm going to combine these two terms. The way I'm going to do that is I'm going to multiply this by 2 square root of x plus 4 over 2 square root of x plus 4 to get a common denominator, like so. That combines into this. The only time this fraction can equal 0 is when the numerator equals 0, so we just have to solve 3x plus 8 equals 0. From this, we see that x equals negative 8/3. And this is our guaranteed value c such that f prime of c equals 0. That's an overview of the mean value theorem and Rolle's theorem.